And for anyone who is just joining us, remind that TechShares are a forum sponsored by OpenTeams for technology leaders to connect with business leaders to help their organizations create better software solutions utilizing open source software more effectively. So for the second session of today, we have Travis Oliphant, leader in the Python data science community with a wealth of experience developing applications and improving software for Fortune 500 companies. He led the creation of many open source cornerstones, including NumPy, SciPy, Numba, Anaconda, the organization's NumFOCUS and PyData, and founded Anaconda and Quansight, along with most recently OpenTeams. He holds a doctorate in biomedical engineering from the Mayo Clinic and a Master of Science in Math and Electrical Engineering from Brigham Young University. So welcome to the second session, Travis.
Thanks, Brian. It's great to be here. Appreciate the opportunity to talk about open source.
Absolutely. I'm enjoying it myself. Looking forward to it. So again, the topic for this second session is how to select the right open source software for your product stack. And I have to assume with your extremely deep expertise in open source, you have a lot of wisdom for us here. So I guess I'll.
A lot of words. We'll see if they're wisdom.
Well, yeah, I guess, yeah, fair enough. We'll leave that to the audience to decide. So as you're well aware, there is an extremely diverse. I apologize, my video seems to be a little bit flaky. And for somebody coming new to it or trying to decide which tooling to choose, it can be a very confusing thing to step into. What is even out there? How do I choose which open source tooling to look into and to invest in time and money to bring into my company or my organization? What should people do to navigate this dizzying array of options in front of them?
Yeah, it's a great question, and I'm gonna tell a little story here that might not seem relevant, but I think it has some corollaries. When I was getting married, I had the same kind of mental thought. I'd met a fantastic woman who's now my wife, but as I was trying to decide, should I, when I was young and I was trying to decide if we should get married or if I should ask her, I would think about this. Wait a minute, what about the rest of the world? What about there may be other people out there that I should choose? My wife didn't really appreciate this line of thinking, by the way. I mean, it's not advisable to mix mental gymnastics with romance, but me, being who I am, I of course had to be totally transparent with her and talk about it. And I in fact wrote an essay about it. But it kind of illustrates the point that sometimes you have to go with what is helping you and what you're not going to solve the whole problem. So don't sometimes we can get paralyzed by having oh, what else is out there? What else could I use? What else could I do? And that's kind of what's happening to me as a young man. And I had to kind of understand, wait, I can evaluate the situation. Here's an amazing woman I have the chance to be with, and I should do it, right? And so in some cases, I'll talk about some of the things you have to consider, but I think my number one point is go with what works for you. Go with what makes sense for you at that moment, and then commit to it and and build it and fix it and prove it. Like I don't once I made a commitment to marriage, I'm not constantly thinking, well, who else could I have chosen, right? Where else could I have gone? I mean, make an investment in that relationship. And for your software stack, it's kind of similar. I mean, it's not entirely the same. So some people will argue about, that maybe making that analogy, my wife being one of them, she'll probably hate this analogy because, a commitment to a person is stronger than a commitment to technology. Yeah. But there's something to learn from the fact that, things are what you make them. Mm-hmm. And if it's helping your business, unless there are concrete things you can point to and saying this isn't working, this is not helping me and I'm actually getting worse, then sometimes just making the software better is what you need. Mm-hmm. So that's one of the things. So we'll probably get into that a little bit later as we talk about what happens when you choose your software. But the factors you consider are really what are your needs, and making sure that what you're a lot of times the choice of software stack is often not intentionally made. That's something I think we should mm-hmm. acknowledge as an elephant in the room. Yeah. In many cases, you end up like the person who's in charge, maybe the person who's in charge of development of a thing that has somebody in the organization has just pulled in a dependency, mm-hmm. kind of without everybody understanding. And then, fast forward 3 months and we're like, oh, we're dependent on this thing that nobody told us, mm-hmm. that we didn't really, because it's so easy. And because it's so productive and it helps developers make so much more improvements. And mm-hmm. I'm not saying you should stop that behavior, because honestly, that's how productivity is happening in the world today. Like right now, people are much more productive by instead of writing everything themselves, going, hey, I have this thing to accomplish, let me go write all the code. They're going, wait a minute, I just going to stitch together some libraries of these that are sitting out there.
The benefit from it personally all the time.
Exactly. So it's not to say that you shouldn't do that. It's just to recognize this is what's the reality. Let's make sure we understand that, and then understand what we're making dependencies on. So part of it is, I think, large good organizations are kind of creating training for their staff, and kind of they're helping people understand, cool, you're going to build on this technology. Let's just have a way to report on it, inform that this is happening, and so that some amount of, before it gets too baked in, some amount of review can take place. Because the things you might care about as an organization, as your developer team is pulling dependencies on open source software, you want to understand some things, like one, what kind of support is available for this. Am I essentially signing up to support this open source piece that I now own, or is there a community out there that I can ask questions to? Is there a commercial company out there that can actually support our use of this software?
Sure.
Those are questions that are really critical to understand. There's also, so we in fact at OpenTeams have come up with an OpenTeams score, which essentially is a business score, so you can kind of at least look at a score of a software you're getting and kind of understand, oh, if it's high score, then it probably has a large range of things. And we're in the process of making open source how we get to this score, so people can see the different components of it and then kind of stitch their own score together based on how they want to weight the different components. Because it has things like, IP. What's the IP licensing? Is that a concern? Is it GPL, or is it BSD? Is it Apache? Does it have guarantees for patent protection? Because there are situations you can certainly stumble into if you're not careful by making an adoption. There's things like, how am I getting the software? It's one thing to go get the source code and then compile it yourself. Not that that's not free of attack vectors. It is. It can if nobody's paying attention to the source code. There's examples of people having injected code into the source code. People unwittingly just pulled it in. So there's that one. But the bigger one is binary. How am I getting the binary? Am I just going to some website that has, does that website provide guarantees of how there's not a man in the middle attack, there's not someone has injected a binary up there? The other thing that can happen these days is people are kind of putting typos on the big package managers, like a large number of package managers out there. People are putting little off by one character packages up there.
Pluralizations
Exactly. So I'm importing pandas and I forgot to put an S on it. I just imported panda, right? I'm not
the same thing.
It's not the same thing, right? And so all of a sudden you find yourself, internally. So a lot of people, making sure as you're pulling in software, you have sandbox areas where people can pull in software, and there's a process to go from I'm pulling in software, and then I can review what my dependencies are, and then when I go to deployment, I'm understanding what that is. A lot of organizations are doing that well. Some not so well. Some need a little bit of upgrade to how they're doing it. So I think you want to enable your developers to make those choices. Like I think it's really bad when you have some committee. Let's say you have 10,000 developers, and you have a committee. You have the Ministry of Open Source Selection. Like I would say, any organization that does that is going to be behind within a year, because you're going to basically bottleneck behind that ministry. They're not going to have enough information. So you want to segment it out to your developers who have the most knowledge, have the most understanding, but then have a little bit of a process. So as they pull a software in, there's a point of review where you can say, okay, well, how are we going to get this software? What is the score associated with it? Where are our risks associated with it? So we talked about IP risk. We talked about often just the community support, community help. Is the community very big? Is it a 1-person community? Is it a 10-person community? Is it a 1,000-person community? How many other people are using this? That's kind of it's sort of like safety in numbers. If a million other organizations are using it, then they're going to have the same problems I do. So at least I feel like I'm not. It's kind of like nobody got fired for hiring X company.
And it's more likely that problems will be found quickly.
Agreed. As the author of NumPy, I've kind of understood what's happening now. Is like nobody got fired for using NumPy. Right, because it's a massive, massive project with lots of support at this point, and lots of people who understand it, and it's evolving. There's things that are building on top of NumPy, like PyTorch and TensorFlow and so forth, and going beyond it. What does the documentation look like? What's the version I'm depending on? These are the kinds of things you have to do. And for more information, I would say check out our work at OpenTeams on the OpenTeams score.
Sounds good. Yeah, good recommendation. So this, what you've described, it kind of is somewhat from the perspective of building something from scratch, and where you have the freedom to choose. You're just building something new, bringing new things in. But there's also situations where you have existing software stacks and existing projects that are experiencing friction or challenges from proprietary lock-in or other issues with the non-open source tools that are out there. So if you would talk a bit about how a company or how an entity might think about the philosophy or the approach to switching to some open source tooling, the benefits that might provide them, but at the same time there are real costs to moving away from an established system that works maybe well enough but has its issues.
Yeah, no, agreed. I think this is at the heart of a lot of people's thought process right now. Um, and one of the challenges, of course, is that innovation keeps happening in technology. I've talked to leaders at large organizations, and many times I've, over drinks or over coffee, I've heard kind of the complaint, like, I spent $50 billion on technology, and I'm still spending $50 billion on technology. Is there never an end? And the answer is kind of no, there isn't. What you have to do is understand what is your spend and how do you get the most out of that spend. And I think there are evolving answers to that question. You have to pay attention to. It's not the same as it was 10, 12, 30 years ago. Like how you get the best value out of that spend is different. So one, you do have to have a real business need to move away from existing software that's working. Like I think honestly, many times it's better, even though I love technology, I love innovation, I love advancement. I'm pragmatic enough to understand that sometimes it's actually not worth it to try to go replace something that's working. That you understand, well, this is working, and let me just shore it up. And then you think about what's the cost of maintaining it. At some point, the cost of maintaining something is going to be more than the cost of replacing. So somewhere in the life cycle of a piece of software, you want to make this decision ahead of that point, because you don't want to be at the point of essentially you're spending more to maintain something than it would have cost every year than it would have cost to replace it 3 years ago.
I mean,
Right.
one of
So
the one of the,
ahead.
like, COBOL in finance seems like a really good case study there.
Yes. Well, COBOL so mainframes are still in practice. There's still a lot of people using mainframes. I know have a lot of friends at IBM, and a lot of people don't realize that IBM still has a lot of revenue because they've built great solutions that are still working for their companies, and they don't need to change them just because the latest fad in technology. They've got an answer that's giving them value and solving a business problem, and is incrementally improving that. They can do it.
Right.
And so, and the mainframes are actually making changes because we're kind of going back to the mainframe. Like the whole move back to the cloud is actually very, very similar to back to the data center.
Indeed.
Where now the cloud is just a new mainframe.
Right.
The cloud is a new mainframe. So, okay, you update the mainframe software and protocols and mechanisms, and now it actually doesn't look that different, which is why IBM's cloud strategy doesn't look strange as you're thinking about how do they compete in a world of cloud. They're doing cloud for years. So I think there's a similar metaphor there of, hey, if you've got a software, one, you do have to be intentional and not be afraid of understanding when software should just be continued with. You don't need to replace it with every newfangled object that shows up. Usually what the best approach is to recognize you have new projects emerging, new things that are happening in your organization, and that's where you can try new technology. Hey, I've got this new thing I'm doing, I want to do, and then can I create there? I'll kind of try something new. I'll try a different approach. I'll try something that helps me. Often there's a new business need. There's quite often, for example, I need speed. I just need this to be done faster. Right. And the only way to get it done faster is to take advantage of, let's say, GPU technology or cheaper cloud technology or a ASIC hardware or something. Like, so there's a new need that shows up that says, like, and once that's there, then it's a straightforward business decision because there's value in the switch. So these are strong drivers to get started with new open source technology. Is I've got a problem I got to solve. Definitely not just because I want a fancy new car. I want the car's helping me. I mean, I don't have a need. But let's say my car's a gas guzzler and it's polluting the environment, and I'm spending too much money on gas. Well, that's represents a different need now. Now that's a reason to kind of switch, an incentive to switch. Same thing in technology. There's stuff that happens all the time. So what happens typically with legacy software is the software becomes expensive to maintain because you can't find people who can the COBOL's a good example. COBOL. My dad programmed in COBOL 40 years ago, right? 50 years ago. And then now people still do, but it's hard to find them. There aren't that many COBOL developers. So if you've got a system that's dependent on COBOL, you have to think, okay, is we going to do this? The cost of maintaining it, hardware, you can often end up situations where actually for that software to work, it doesn't work on newer hardware, right? And so you've got to basically maintain hardware that you don't, in extreme circumstances like the space shuttle or the space program, they've got dependency on hardware that doesn't even exist. And so how do you get replacement parts for that, x86, that 8086 or 8286?
Simply not made anymore. Yeah.
It's just not made anymore. And so the supply chain and things you take for granted aren't there. So there is a reason to stay current, but as a business, you don't have to stay ultimately current. There's a 10-year gap usually. And frankly, Brian, I think a lot of lessons were learned in the migration to cloud, which is still ongoing, and that are relevant here. It's like, yes, we should use the cloud, but we don't have to just wholesale jump to it and just stop everything we're doing here. So I think those are, making sure you're staying ahead. You do have to have an approach here, especially as you have new things that new business practices that you need to take advantage of newer technology, or the business doesn't work.
Yeah. No, all very good points. So one of the things you mentioned, you touched on briefly earlier that might be worth leaning into a bit is the question of the IP and licensing question, because that is whether you're a company or whether you're just an individual with a side project, considering the licensing and the usage aspects of the dependencies that you take on is a significant practical consideration. What are your thoughts on educating oneself on business considerations as you think about dependencies, open source dependencies to bring on board?
So you broke up at the very end when you were finishing your question. But it's about the licensing concerns and the business considerations about licensing.
Yes, so what are some of the pitfalls that businesses might face if they make a poor choice and bring in a license that messes things up?
Yeah, well, and this is an area of, lots of open source participants have heated debates and have had heated debates over the years about, the right license to use, and it's evolving. But there are real consequences. We'll talk about three categories of licenses. One is a license that says it's the GNU license family, and there's differences between the LGPL and GPL, but the straight up GPL and AGPL is a new one that has additional restrictions. But effectively, it's a license that says, here's some free software, go ahead, but there's restrictions if you publicize or publish modifications. So if you use it internally, it's fine, actually. You can use it internally and nobody ever sees the light of day. Doesn't matter, you can use GPL all you want. Now, there's some legal ramifications of using it internally for a multinational organization where you have multiple entities. Are you actually publishing that work to other entities if you're a multinational? There are some nuances there that, again, most of this has not been tried in court. There isn't legal precedent here. It's actually a lot of mental thought, just people concerned about what they can get in trouble with. But so there's those kind of licenses. Many companies, because of the uncertainties, have just said, we don't want to deal with that. We're not going to allow GPL.
Yeah.
Now, in practice, a lot of software has started to adopt AGPL these days, more than in the past. So there are actually a lot of companies who are now inadvertently essentially getting dependencies on AGPL software. AGPL is simply, it's kind of the reaction to the fact that large cloud organizations are making a lot of money off of open source, and that's not coming back to the creators of open source. So if you're shipping Mongo and you have a company that has a commercial version of Mongo, and you're trying to help, you want money to go to the commercial company backing the open source software, then a large cloud vendor steps in and just offers the same service for free, and they don't for lower price. It's disrupting that business model. Now I'm not gonna chime in on the debate there about the proprietary of that. I'm just saying that's what's motivating the AGPL.
Yeah.
So AGPLs are basically, you can't do that. If we make it some AGPL, if you even use it to host a service, you have to give back any changes. You have to publicize what you're doing. So you basically have to make open source your server side code. So that's one issue. The GPL issue is a whole one set of things people think, oh, is that a risk I'm willing to take in this part of my code base? And there's another tranche, the BSD MIT license, where it's like, hey, use it, just don't blame us or sue us.
Right.
right? Use whatever you like. And there's a lot of people in that category. And there's a newer frame called Apache, and the Apache license family has the new extra positive clause where people say, if you are committing code, if you're providing code to this Apache licensed software, you're committing that there is no patent attached to this code. So MIT and BSE doesn't mean there are patents, but they don't make that, they don't require that assertion. Whereas Apache license code requires the contributor to make the assertion essentially that there aren't patents or other,
it's not
patents,
encumbered. Yeah,
it's not encumbered with this extra IP clause that isn't clarified.
Right.
And so many people really like the Apache license because it sort of helps them be, ultimate. So from a business perspective, you can kind of order these, roughly. And again, cases will vary and people have different stories, but Apache, MIT, GPL, effectively because of the different risks that are associated with it. So that's an example of kind of, now in a practical situation, a real situation, you do have to get a little more detailed than that. Like that's kind of a high level view, but you need some more perspective in order to really understand what your risk is.
Indeed. So we're getting close to the end of time. We want to leave a little bit of time if there are any questions from any of the attendees. I don't see any at the moment. If anybody does have any, pop them in. But until I see some come in, one of the things that you certainly have to deal with when you're so you mentioned the one great place to try to move to open source is when you have a new initiative or a new need. But whether you apply it there or whether you're trying to replace a component, you do have to be concerned with compatibility of those no pieces with any existing code.
Yes.
So what do you have some direct experience there or some thoughts there? How do we make sure that the new open source pieces play well with the?
Yeah, I certainly have experience seeing this at scale, and I would say lots of effort has gone in large organizations to try to handle this to various degrees of success. How much a new software project will cause some amount of disruption. Like it will, because just simply it's going to say, here's a new file format that has to be supported, or here's a new process, or here's a new UI, or here's a new system that somebody's even simply for if you have a manifest of software dependencies in your organization that has to be maintained, it's altering that manifest, right? So everything you do is going to have some amount of disruption. The question is, how much rework is it require? And it really kind of depends on where your legacy system or where your older systems fit in the life cycle of software engineering. Life cycle is the wrong word, in the maturity of software engineering practice. 50 years ago, software engineering was, how do I even write this stuff? How do I get the computer to do what I want it to do? And so there's massive, so you'd have this huge stack, and then you'd have all this abstraction you build in order to accomplish what you're trying to do. And then of course, okay, what about somebody else and their other abstraction? So you'll end up with these language systems and frameworks that have they again, back to the framing problem, a framing problem notion we talked about in another session. Computer languages have the same challenge as there's a framing of how to think about logically solving that problem. And you end up with a framing that is not, there's nowhere to hook. Like how do I, even that, so one of the innovations over the past 10 years has been this notion when the web and the fact that I have these APIs, I have RESTful APIs, this is sort of a follow-on to SOAP and XML and kind of other ways to have websites talking to each other. But there's sort of this emerging this notion of server-side architecture, which is effectively, let me see if I can encapsulate what I'm doing in a function that passes well-known objects, or if they're not well-known, they're very easily described with JSON. So that I can be really explicit about, here's my interface, here's what I do, and here's my interface. And that software engineering innovation, which is basically, let me solve a problem and publicize how I'm solving it, what I'm solving. So reuse, it really amplifies reuse. At the end of the day, you're how much reuse is possible of your existing systems, and a lot of that has to do with, and many times actually today, it's totally possible to take a legacy system and encapsulate it in a reusable function like that. You can actually wrap a RESTful API around a legacy system
Sure.
fairly straightforwardly,
Mm-hmm.
and so then make it accessible to something else,
Mm-hmm.
right? There might be, 99% of the cases that's possible.
Mm-hmm.
There may be some situations where there's more difficulty, but so that has simplified the problem, but
Right.
it's also, that doesn't work for certain kinds of problems where speed, parallelization, I got to
Totally.
do that is a problem, because all of that,
Yeah.
any time of wrapping puts a latency delay at least,
Mm-hmm.
and sometimes a throughput delay, throughput shrinkage as well. Like I have constraints, so
Yeah.
if I'm really operating at the edge of speed or the edge of size, some of these software engineering techniques don't work, and I'm kind of back to the old days of, let me just make something that works. And then
Mm-hmm.
and if you built something like that, and that's what you're depending on right now, that's going to be hard to integrate with.
Yeah.
And so you may have to think about integration a little different way.
Yeah, one of the most entertaining examples of that kind of wrapping legacy that I've heard of was somebody who used a mouse pointer driver to to automatically interact with a graphical user interface on an
Yes.
old piece of software to do what they needed to do. But there's no way in the world that you could parallelize or scale that. It's all
Yes, right. That's a great example,
bound.
Brian. Yeah, good point.
So,
So I think fundamentally, and this is also matches my philosophy of testing. Like, as you have a piece of software you rely on, testing becomes more and more important. You really need to be able to automate and test what your reliance is. And
indeed.
so that's, testing is the key
Mm-hmm.
to understanding whether that disruption is going to hurt you or not.
For sure. All right. Well, we are at the end of the session. Again, it's been a terrific conversation, Travis. Thank you so much for your time. Really appreciate it.
My pleasure.
And look forward to hopefully doing another session sometime soon.
Thank you. Thank you, Brian.